I want Fred and Mary to move away from each other slowly, because they're turtles after all, they move slowly, continuously, and at the same time. Those are my requirements. Not Fred moves forward by 300 steps and then Mary moves forward by 300 steps. How can I break this down in a way that makes it appear as though that's what's happening? And one solution is to make Fred move by a small amount, let's say 1 step for now, and then make Mary move by 1 step, and then ask Fred to go again by 1 step, and Mary by 1 step. Fred, Mary, Fred, Mary. If they all move by 1 step, both of them move by 1 step each, one at a time, that will be close enough to what we want, right? Because they're only moving by a small amount. If I make that step really small, I won't be able to see that Fred is moving by a bit and then Mary by a bit. I'll be able to see them moving at the same time. We will be able to make them move exactly at the same time. That's going to come later in the scores. But for now, this is going to be good enough. So let's stick with 1 step. Fred and Mary move forward by 1 step each. And if I run the code, I'm not going to see anything there. If you run it and you look really closely, you'll see them move by 1 pixel each, but it's very hard to spot. What do I need to do next? A common question we ask ourselves when we're coding is, good, this is what my program does. What do I need to happen next in my program? I would like Fred and Mary to move again. Now, Fred is moving by 1 step, Mary by 1 step. Fred by another step, Mary by another step. Can you see them there? Now I could sort of see them a bit more. They've moved 2 steps. Let's go again. They've both moved by 3 steps now, but not 3 steps for Fred and 3 steps for Mary. 1 each, and then 1 each, and then 1 each again. And let me do another one. And you can see that it's working. The problem is, there are 2 problems really. First of all, I want them to move away forever. Now, we could argue, well, as long as they've left the screen, that's as far as I want to copy paste, right? And once they've left the screen, I can ignore it. But that's not forever. There are things in programming we want to actually happen forever. I cannot copy and paste forever. Otherwise, I'm copying and pasting and never being able to run the code. So that doesn't work. But there's also another principle. And this is one of the most important principles in coding. The acronym is DRY. And it has nothing to do whether it's wet or dry, whether it's raining or not, wherever you are. DRY stands for don't repeat yourself. And this is a concept that is key to so many things in coding. In fact, the acronym DRY is one we use a lot. Sometimes you hear people say, this code is not very dry. We need to make it more dry. I'll tell you in a later session about the opposite of dry, which is wet. But wet doesn't obviously exist, but we sometimes say code is wet. The meaning is it's not very dry. I'll tell you more about that in a bit. So you can see why this code is wet. It's not dry because I'm having to copy and paste. I'm doing lots of work. I, as a programmer, am lazy. Efficient is a nice way to say it, right? But we've got permission to be lazy. We as programmers want to do the least amount of typing and hassle as possible. It's fine for the computer to do it because the computers are quick, they don't get bored, they don't complain. So we want the repetition to be done, not by us, the human beings, but by the computer. So let's get rid of the repetition and let's keep Fred. In fact, let me remove these for now as well, just to make it easier. How do I get the computer to repeat things for me? There's more than one way. We're going to look at one of them now, and then we'll look at more later in this course. And I'm going to start by asking the computer. So I'm going to write this and then I'm going to sort of explain a bit what's happening. While true, and a colon. So there's a lot happening there that we haven't seen. While is what we call a keyword, just like import. And it's the keyword we use to tell the computer, I want you to repeat something. We'll see exactly what's going to be repeated. True is a word that exists in Python. It's another object. You know, we talked about objects earlier. We had our turtle.turtle object. We have a string. Whenever we put something in quotation marks, true is also an object. It's yet another special type of object that can only take 2 values, true or false. We'll talk more about this in a bit. And then I've got the colon. The colon is another punctuation mark that we will see very often in Python programming. We've seen the parentheses many times. We've seen the dot many times. As a reminder, the parentheses is a way of saying, do this command now. The dot, you can think of it as a way of connecting things together. The colon means coming next is a chunk of code, is a block of code that belongs together. Now, while true, let me translate this for now from Python to English. While true is asking Python, please repeat the following lines forever. So please repeat the following lines forever. That's what while true is saying. We'll dig a bit more into what's happening here as we go through the rest of this chapter. Notice what's going to happen when I hit enter. Of course, you know we're going to go to a new line, but there's going to be something specific about where we go on the new line. Ready? You notice that gap, that indent. This is a really important part of Python's grammar, Python's syntax. And I'll tell you in a second what it does. Let me say I want Fred to go forward by 1 step, and I want Mary to go forward by 1 step. And that's it. Let's run this code and see what's going to happen. And you can see there that Fred and Mary are moving away from each other. At the same time, we can't see it. Technically, they're moving 1 step and 1 step, but it's good enough. And they're going to keep doing this forever. Even when they leave the screen, nothing in my computer program says stop Fred and stop Mary when they leave the screen. Even though you can't see them and it seems obvious that they should stop, well, they haven't stopped. In fact, if I make this window a bit bigger, have we lost them? Was I too slow there? There they are. We can still see them moving. And even now that they've left my entire screen, that wasn't just the window, now they've left my entire screen, the program is still moving Fred and Mary because we said keep doing these 2 lines of code forever. Keep moving Fred forward by 1 step, then Mary forward by 1 step, then Fred forward by 1 step, then Mary forward by 1 step. So while true is our way to tell a Python program keep repeating the following lines forever. Now it's a strange phrase, if you like. Well, it's not a phrase, obviously, because it's not English. This is something else. This is what we call a statement in Python. We'll see why it's strange, or rather, I'll tell you why it's strange now, but we'll see why it has to be this way in a bit. Because while is a keyword in Python that needs to be followed by something that Python understands is either true or false. Why? Because we're going to be able to say, instead of repeat forever, repeat until something else happens. And the way we're going to do that is by finding a way of telling Python that if something happens, we want this to become false, or something that Python understands as false. And that will be the signal we're sending the computer program to stop repeating. So for the time being, we are repeating forever. But the reason we have this rather strange true there is because the while loop, we call this a while loop. A loop is something that repeats, and we have more than one type of loop in Python. So this is the while loop because it starts with while. So the while loop needs to have something which Python can understand. It's either true or false. But by putting the word true there, which Python understands, this means this will go on forever because while has true after it. This will make more sense as we move on in this Fred and Mary project.